Quantum physics might sound intimidating, but what if I told you it explains how the universe works at its smallest level? That's right, we're talking atoms and particles. Quantum physics governs these tiny realms. It's a world of mind-bending concepts. But fear not, intrepid explorer. We're about to embark on a journey to demystify quantum physics. Get ready for simple explanations and relatable everyday examples. Let's dive in. Imagine shrinking down to the size of an atom. In this quantum realm, the familiar rules of physics no longer apply. Particles like electrons and photons behave in unpredictable ways. They don't follow the same laws of motion as larger objects. In the quantum world, things exist in a haze of probability. It's like flipping a coin that can land on heads, tails, or both at the same time. This strange behavior is what makes quantum physics so fascinating and challenging. Let's start with light. We usually think of light as a wave, right? Like ripples on a pond. Waves have crests and troughs and they spread out over time. But here's the kicker. Light can also act like a particle. These particles of light are called photons. Photons are like tiny packets of energy moving at incredible speeds, so light can be both a wave and a particle. Weird, right? This is called wave-particle duality. Fascinating, isn't it? Now you might be wondering if light can be both a wave and a particle. What about matter, like the stuff we're made of? Well, guess what? Matter can also exhibit wave-particle duality. Electrons, which are tiny particles that make up atoms, can behave like waves too. They can spread out like ripples and interfere with each other. It's like throwing a baseball and watching it diffract through two slits at the same time. Mind-blowing, I know. Section 5, superposition existing in many states at once. Hold on tight because it gets even weirder. We're diving into the mind-bending world of quantum mechanics. In the quantum world, particles can exist in multiple states at once. This phenomenon is known as superposition. Imagine a world where the rules of classical physics no longer apply, and particles behave in ways that defy our everyday experiences. Think of a spinning coin. As it twirls in the air, it hasn't yet decided whether it will land on heads or tails. Until it settles, it's both heads and tails at the same time. This is a simple analogy to help us grasp the concept of superposition. Similarly, a quantum particle can be in multiple places, or have multiple energies simultaneously. It exists in a state of probability, where all possible outcomes are possible until we observe it. It's only when we measure it that it collapses into a single state. This act of measurement forces the particle to choose one of its possible states, a process known as wave function collapse. It's like the universe is waiting for us to observe it before it decides what's real. This idea challenges our understanding of reality and suggests that observation plays a crucial role in the behavior of quantum particles. To illustrate this further, consider Schrödinger's cat, a famous thought experiment. A cat in a sealed box can be both alive and dead until we open the box and observe it. This paradox highlights the strange and counterintuitive nature of quantum mechanics. Superposition is just one of the many fascinating aspects of quantum mechanics. It opens the door to a world where particles can be entangled, influencing each other instantaneously over vast distances, and where the very act of observation can alter the outcome of an experiment. As we continue to explore and understand these quantum phenomena, we unlock new possibilities for technology and deepen our understanding of the universe. The journey into the quantum realm is just beginning, and who knows what other mind-bending discoveries await us. Section 6. Entanglement, spooky action at a distance. Now let's talk about entanglement. This phenomenon is one of the most fascinating and perplexing aspects of quantum physics. This is where quantum physics gets truly mind-boggling. Entanglement challenges our classical understanding of the universe. Imagine two particles that are linked together in a special way. These particles become entangled, meaning their states are interconnected. Even if you separate them by vast distances, they remain connected. This connection persists regardless of the space between them. If you measure the state of one particle, you instantly know the state of the other particle, no matter how far apart they are. This instantaneous connection defies the speed of light. Einstein called this spooky action at a distance. He was skeptical of the idea as it seemed to contradict his theory of relativity. It's like two coins flipping in perfect sync, even if they're light years apart. This synchronization is not due to any signal traveling between them but rather an intrinsic connection. Entanglement has profound implications for our understanding of reality. It suggests that particles can be connected in ways that transcend our conventional notions of space and time. This phenomenon is not just a theoretical curiosity, it has practical applications in the emerging field of quantum computing, where entangled particles can be used to perform complex calculations at unprecedented speeds. Additionally, entanglement is being explored for use in quantum cryptography, which promises ultra-secure communication methods that are theoretically unbreakable. Imagine a future where information can be transmitted instantaneously across vast distances thanks to the principles of quantum entanglement. This could revolutionize how we communicate and share data. As we continue to explore and understand entanglement, we may unlock new technologies and insights that could change the world. The spooky action at a distance is not just a mysterious phenomenon, but a gateway to the future of science and technology. Section 7. The Uncertainty Principle, Embracing Fuzziness. One of the most famous concepts in quantum physics is the uncertainty principle. It states that you can never know both the position and momentum of a quantum particle with absolute precision. It's like trying to nail down a cloud. The more you try to pin down one property, the more elusive the other becomes. This isn't a limitation of our instruments. It's a fundamental principle of the universe. Embracing this inherent uncertainty is key to understanding the quantum world. Section 8. Quantum tunneling. Through walls of impossibility. Imagine throwing a ball at a wall. You'd expect it to bounce back, right? But what if I told you that in the quantum world, things don't always follow the rules we're used to? Well, in the quantum world, particles can sometimes tunnel through barriers that seem impenetrable. This means that instead of bouncing back, they can actually pass through the wall. This is called quantum tunneling. It's a phenomenon that defies our everyday experiences and challenges our understanding of reality. It's like the ball magically appearing on the other side of the wall. Imagine the surprise if you saw that happen in real life. This bizarre phenomenon is possible because particles behave like waves. In the quantum realm, particles aren't just tiny dots. They have wave-like properties, and waves can spread out and pass through obstacles. Just like how water waves can bend around objects, quantum particles can find a way through barriers. Quantum tunneling plays a crucial role in many natural processes, including nuclear fusion in stars. Without it, the sun wouldn't be able to produce the energy that sustains life on Earth. It's also essential in modern technology. For instance, quantum tunneling is a key principle behind the operation of semiconductors and the microchips in our electronic devices. So the next time you use your smartphone or computer, remember that quantum tunneling is at work, making it all possible. This incredible phenomenon shows us that the universe is full of surprises, and there's still so much to learn and discover. Quantum tunneling is just one example of how the microscopic world can be vastly different from what we experience every day. It opens up a realm of possibilities that challenge our imagination and push the boundaries of science. Section 9. Quantum Physics in Action, from lasers to MRI. Quantum physics isn't just theoretical. It has real-world applications that shape our lives. Take lasers, for example. Lasers rely on the quantum properties of light to produce highly focused beams. Medical imaging techniques like MRI, or magnetic resonance imaging, also depend on quantum physics. MRI uses the magnetic properties of atomic nuclei to create detailed images of the inside of our bodies. From smartphones to computers, many technologies we use every day wouldn't be possible without quantum physics. Section 10. The future is quantum unlocking new possibilities. As we delve deeper into the mysteries of the quantum world, we unlock new possibilities for the future. Quantum computing, for instance, has the potential to revolutionize fields like medicine, material science, and artificial intelligence. By harnessing the power of superposition and entanglement, quantum computers could solve problems that are impossible for classical computers to tackle. The future is quantum, and it's full of exciting possibilities waiting to be explored. Section 11, keep exploring. The universe is your oyster. So there you have it, a glimpse into the mind-blowing world of quantum physics. From wave-particle duality to entanglement, these concepts challenge our intuition and expand our understanding of the universe, but this is just the beginning. There's so much more to learn and explore. So keep asking questions, stay curious, and remember, the universe is your oyster. Who knows what other mysteries await us in the quantum realm?